Welcome back everyone. So in this session we are going to understand about congruency. What is meant by congruency and what is congruency, what is its various criterias. We are going to dig deeper in congruency, but let us firstly let's have a look at these pictures. Now as you can see, let's name these pictures. This is my first picture and this is my second picture, right? So if I talk about picture 1 and picture 2, can you find any difference in shape? This is a pure rectangle, this is also a pure rectangle, as well as picture 1 can clearly superimpose picture number 2, right? So here is one term that comes that is known as superimpose. Superimpose, what is meant as superimpose? That it perfectly overlaps. For example, my two hands, right, they are perfectly overlapping each other, right? So superimpose, these two notes can superimpose each other. Let us have a look at one more image over here, and that are bank ATM cards, or you can say credit cards. So as you can see, we have 4 credit cards over here, and these all are some banks platinum cards, but let's say these all are different cards. Now can you point out the difference between the shapes of these 4 cards? No. Again, all of these cards can superimpose each other, right? And this is where my definition of congruency comes. So congruency, if I talk about congruency, so congruency is what? Congruency is a property, is an observation in shapes. The two triangles, the two shapes, the two rectangles can be congruent if and only if they can superimpose each other. For example, this is triangle A, B and C, and let us draw a same dimension triangle D, E and F, right? So I have two triangle 1 and triangle 2. I can say these two triangles are called perfectly congruent. So triangle 1 and triangle 2 are congruent, and these are congruent. That directly means that triangle ABC and triangle DEF can superimpose each other. Superimpose each other. I hope it is making sense. Now, in terms of notation, how we can represent these two? So this is the notation of congruency, right? This is the, so congruent, if I want to show that anything is congruent, this will be my symbol for congruency. Now here is few implications. I can take directly from here implications. What would be the implications? Firstly, angle A will be equals to angle D, angle B would be equals to angle E, and angle C would be equals to angle F. That all the three angles are separately equal to each other. Second, AB is equals to DE, BC is equals to EF and AC is equals to DF. These are two important implications if I say that triangle ABC is congruent to triangle DEF. Now let us have a look at some properties of congruencies. Properties. What are its various properties? Now, the very first property is that every triangle is congruent to itself. This is pretty much basic statement that whatever the triangle is, it will always be congruent to itself, that is, it will always superimpose itself. So that is obviously true. Next one is, if I talk about triangle ABC, if this triangle ABC is congruent to triangle DEF, then what I can essentially say that triangle DEF will also be congruent to triangle ABC. I hope it is making sense to you. And the third property what we have is, if triangle ABC is congruent to triangle DEF and triangle DEF is congruent to some triangle, let's say PQR, then what I essentially can say that triangle ABC will also be congruent to triangle PQR. So these three are my basic properties of congruency. I hope it is making sense to you. Now there are various criteria as well whether the triangles can be congruent or not, right? So these criteria we are going to study in next concept. That's all for this concept. Thank you so much.